Okay, let's talk functions. Why do we need them? Why do we need to worry about that? So the idea behind functions is we want to break our programs up into smaller bits. Let's take a look at what I have on screen right now. Now, the actual code, I'm not going to go over this line by line. There's a couple of reasons for this. One, there's a lot of code here. It would take a bit. Two, I'm doing a lot of things in this particular project that go way beyond what's necessary or even advisable to cover in a programming fundamentals class. And finally, honestly, it's not the best code. I wrote this very organically, just sort of as a way to learn Pygame and refresh my memory on a couple aspects of Python. And so this is not good, well organized code at all to be learning off of. But it does help me illustrate the point for functions, because this is a far more complicated program than anything we've taken a look at so far. Also, ignore the fact that I'm in Visual Studio instead of Visual Studio Code. So if I run this, it's just a very simple, silly thing. You have a little character that moves around. If you press and hold the space bar, you fire. As you can hear, there is sound. There's a score, and I can't go out of bounds. You hear me tap the keys there, trying to go out of bounds. And nothing happens when they touch you other than some console messages. Even have some debug information where I can see my frames per second and collision boxes. So it's a reasonably complex little program. And for the keen-eyed amongst you, yes, those are Vampire Survivor assets. That actually, the Vampire Survivor assets, for the most part, come from a purchasable asset pack. So I did not rip those off of Vampire Survivors. I purchased them. Okay, so what is the point behind this? Well, let's look at my PyDungeon, the code that I have here on screen real quick. You notice I've got a lot of functions, and these are functions that I have written. So register main screen, init all list, load player, load projectiles, load monsters. These are all functions that I wrote. If I come over here into Game Manager, and see here's where we're setting everything up. And then here's where I'm initializing lists. And here's where I'm loading player assets. Here's where I'm loading monster assets, projectile assets. Um, and then every single frame, 60 times per second, I need to call update and I need to call render. And then I also need to do these checks here. And so there's a lot going on here. And if I take a look at game object, every single game object has collision information, loading images, rendering. Projectile has its own information for updating itself, determining directions to go, whether or not it's collided with something, etc. Same thing with player, same thing with monster. I could, technically speaking, it would be a nightmare, but I could write all of this in a single file. But and I could write it in a single file probably without using functions. It would be a nightmare task though. It would be a nightmare to write. I would have repeated code everywhere, which would make debugging orders of magnitude more difficult than it already is. It would just be a mess. It would be a true disaster to try and write this program without having my own functions written. And even besides this, we've been using functions this entire class. Print is a function. Input is a function. Int is a function. The random dot randint is a function. All of these are functions. They are self-contained little bits of code that you can call and use from wherever you need to use it from. And again, I want to take a moment to just talk briefly again about code reuse, which is one of the things we talked about way back at the beginning of class. Do not fall into the code reuse trap. Write your code such that it works for the project at hand, especially for this class. You will not be, with the exception of one thing, you will not be reusing code. And that one thing we will talk about here momentarily. But for the most part, you won't be reusing code in this class. Like I said at the beginning of class, about the only time that you really worry about code reuse is if you are deliberately writing an API. If you're deliberately writing code for many other people to use. That's when you start worrying about engineering perfectly generic, reusable, and who knows what scenario code. All the code in this project here, yeah, no, it's going to break instantly if you try to pull it out into a different project. It just ain't going to work. But that's not the point here. The point is this project needs these functions because otherwise I wouldn't have been able to write it. Just, again, is it technically possible? Yes. Would I have ever succeeded? Probably not. I would have given up in frustration way before it finished. So that is why we want to write functions. So let's take a look at how we actually do functions. Let's say I want to write a function to add two numbers together. Now, it is important to note that you would never actually do this, because if you want to add two numbers together, I would say x equals 5, and don't type this in, y equals 3, and z equals x plus y. I would not write a function to do this, but it's a very easy to understand thing. So the function, in order to start a function, we need to start off with the def keyword. Again, I am assuming that you have read the W3 Schools material. So we start off with the def keyword, then we have to give the function a name. Functions follow the same naming rules as variables. Now, convention, my convention is I always start functions with a capital letter. That's my convention. Is that mandatory? Is that a rule? No, that's just, you will always see me write functions starting off with a capital letter, and I will, as usual, use camel case when typing it in. So I'm going to say def add two numbers. Then we're going to have a set of parentheses, and this is going to be the information that we pass into the function. Sometimes we don't pass information in. And you saw that in the code that I was just showing, where I had all of those init functions. They had things to do, they had data to transform, but I didn't have to pass anything in. In this case, however, I need to pass in variables. And all this is a comma-separated list of variables. You can technically put in as many variables as you want. Theoretically, yes, you can have so many variables that the function will fail. You have to very deliberately try to break a function in order to reach that limit. So effectively, you can have as many variables as you want in a function. Once you are done defining your function, just like with if statements and fors and etc., we need to tell Python that we're done with this line, one of the few instances that we do. So we have to put in the colon. And now every line that we write underneath this will belong to the function. So I'm going to say result equals number 1 plus number 2. Now, we have to talk about scope here. Result only exists inside of this function. If I come down here and I say x equals 5, y equals 10, and then I call add two numbers, xy, and then I attempt to print out result, ooh, I'm getting squiggles. result is not defined. Yes, it is. It's defined right there, right? Scope. A variable that is defined inside a function only exists within that function. Result was defined inside of add2numbers. It only exists inside of there. And you can make things even more confusing for yourself by having a result defined in the main area and a result defined in a function. These are now two separate variables. If I hit run, my output is going to be 0 because that's how result is defined at this scope level inside the main. So how do we get the information out of a function? There's a couple of different ways of doing it. The primary way and the only way we're going to look at in this class is to return a value out. So if I say return result, what this does is after I call this function, when it hits this line, it's going to say, okay, whatever value this is, this function will now evaluate to be that value. So instead of what I had before, this is what we want to have now. So we've defined our x and our y. I'm going to say result equals add2numbers, and then I'm going to print the result. $15, exactly what I expected to have my value be. To drive home the fact that you don't need to have input for functions. You don't need to put this, by the way, so before I do that, sorry, I had a little bit ahead of myself. This is the end of the instructor-led demo as far as what you need to submit. Save your code, upload this to GitHub Classroom. That's what you need to do. This next bit I'm just sort of showing as a further demonstration of functions. You don't need input. I mean, I'm not going to count you down if you submit this in, but you don't have to. So I'm going to say def print hello 10. I'm not going to give any parameters. I'm just going to say for underscore, thank you, in range 10, print hello, and then call the function. Remember, our functions, just like any other function that we've used so far, always have to have the parens, even if there is no parameter. Like I'm not passing any parameters into print hello 10. I still must have that empty set of parentheses there. If you don't have the parens, a function will not work. So if I try to call it like this, I get 15, but then nothing else happens because it just like, well, okay, I don't know what you want me to do with this variable name here, user. But if I put in the empty parens and run it, there we go. So if you have a function that you're convinced that you have written it correctly, but yet nothing's happening, check to make sure you have your parens. And that is it for the function lecture. Now, as far as the assignments go, roll dice, pretty simple one. Write a function, as it says, to roll a set number of dice. So again, your output does not need to be match my words exactly, but I prompt the user, how many dice do you want to roll? 3, sides 6, rolls 3d6. You always have to roll at least one die, and it has to have at least 2 sides, as per the instructions up here. And if either of those is incorrect, display an error message. You can display a combined error message like I have, an error message unique to each condition, your choice on that. And then just as a further example, I'm saying I want to roll 20 dice, 20 sides, and there we go. There's the 20 dice that were rolled. Oddly enough, I got four sixes, geez. 3 6s in a row. The odds on that are low. In any case, that's roll dice. Pretty simple. Write a function that does that. Check input is the one that I was mentioning, that this is the one that you might actually want to move this to other projects, because there will be, from this point moving forward on assignments, an insistence that input is correct. Like if the user gives bad input, the program shouldn't crash. The program will continue to work. And this function can help you do that. Now, again, this particular assignment has a little bit of research. You've seen it. I've shown it, but I haven't talked about the try block. You will need to use the try block in order to do this program. I am not going to explicitly cover it. Again, one of the core skills of a programmer is being able to research. And so the try block is the thing that you are going to have to research in order to effectively do this assignment. And that does finish everything. So good luck with the assignments. I'll catch you in the next video.